We have here the basic idea of the function of f, the function of x graph, and then we're going to do a little bit of the transformations around this graph when you increase the numbers either in front of the x or after the x. So first of all, I'm going to show you, we move up here to this equation right here, that if we change the numbers to 2, we see that we make our graph look more steep. And if we change it to lower numbers, say to a 0.5, our numbers get a little bit less steep. We're going to go and do negatives here in a moment, but in the back there you can see that there's that +0. That meaning you can lift. This means that you can lift up the graph by 3 or 4 by increasing that last number. Let me go back to 0 here, and then we'll start back at 1, and we'll just change the idea to a -1, and we slant entirely the other way. -2 gets even steeper, and -3 even more. So back here to say -1, and the transformations work in the same way. Lift it up by 5 and lift it up by 8. That's just a very basic idea of the graph of what the function of x looks like and how to manipulate some of the transformations of this graph. I'll just set this back to the original. Okay, we have here an x squared function, and we want to see, first of all, this is what the function looks like. It just means that if you go to 1 squared, you get 1. If you go to 2 squared, you get 4, and then 3 squared, you get 9. But we can move around and play with this function, and let me move up to this more complicated equation up here, so that you can move the number in front of the x squared, and you can move the number behind the x squared and change what this looks like. So if we go to 2, we see that it gets tighter, or 3, or even go to a 0.5, it gets broader, and a 0.2 even flatter. But then let's say we wanted to move it up by 1 or by 5. So the back number here moves it up and down this scale while this number changes its opening to be either tighter or flatter. And then let's say we wanted to flip it. To flip it, we just go to a negative. So -1 and -3. Let's say at -1 and then move it up and down. So let's go to 5, 6. So those are some simple transformations and manipulations of a graph. What we have here is the function when looking at x squared, actually x cubed, x to the third. And we can see here that there's a main difference between x squared and x to the third, and that is this, that the graph actually s's instead of making sort of a U shape. So here it was in the U shape at x squared, but when we make it to x cubed, it goes both into the positive side and then into the negative side. And I'm going to look at some of the manipulations of this with transformations. So you have this more dynamic equation that we have right here. We can change the steepness like before. If we go to say the 3 in front of the x right here, if we change that to a 3, we see we get a little bit tighter, closer in together. But if we go to say 0.5, it eases out, and 0.2 it eases out even more. But let's look at something that's unique to this type of graph. It's that when you go upward by these numbers, by the exponent here, when you increase, it's one of the few things that will do this. So if you start out at 2, you're in this position. If you go to 3, you flip, but 4 goes back. Now I'm going to zoom in a little better on this other graph here, and you can see the details of what this transformation looks like. Actually, when you do the exponent, it's not really considered a transformation. That's just changing the entire function. But I want to show you what it looks like when you do change the information. So we have here, this is a bigger scale. This is a scale up to 150, where our other scales were usually 10 or 20, 10, 30 range. And it's not as wide this way because it's a quick change. It's a quick increase and a quick decrease. And I'll show you what I mean here. Let's start out with 2. And this looks very broad. This looks very flat because our scales are different. Before it looked more like this because the scale wasn't so elevated high. But I have to do this so you can see what happens when we go to x cubed. And then let's go to 4. It's going to flip back to the U shape instead of the S shape. And then 5, I'll do it again. Now look at 5, and I want you to see how it gets, because of the being 5 instead of 3, that this part gets tighter in here automatically by going from 3 to 5. And then 5 to 7. So every time you increase this number, you're getting tighter this way also. But you could also use, just like before, the transformations. And let me come back to show this. Let me go to 3. And let me move back over here. You could also use the transformations here to move up and down. So we go to a 5 or a 10. It moves upward. Now let's also do the negative. Let's go to -1. Now your intuition says you want to be on the other side, because let's look at this. Your intuition is that if we started out with x squared, that's a mistake. If we started out with x squared and we were on the line, if we flipped it to a negative, we would just go underneath. This graph does two things when it's x cubed. It is going to flip, see, you all can already see it. It is going to flip and change to the side. So this will flip but also go on opposite sides, like that. And then even from there you can move it up to 5, 10. So that's a little video on the different transformations of the, and this is playing around with the exponents here, from 2 to 3, 3 to 4, and the way that this graph will change in appearance by changing that. So this is our standard appearance right here, and x to the 3rd.